Today we are going to be doing Chapter 6, Section 3, Molar Mass, which is a little bit different than AMU. We saw AMUs at the beginning, the first section of this, and it's an atomic mass unit. And sometimes this is tricky for kids because we would say, okay, look at the periodic table, and for instance, hydrogen. Hydrogen is one atomic mass unit. So it's not something we can weigh out, though. An atomic mass unit is tiny. That is for one atom, right? One atom weighs 1.00. It's something that we can't really conceptualize because it's so tiny. So we're going to look then at what we call molar mass. So it says, looking at these two words, molar and mass, what definition can we come up with? So I'll give the kids a second to think about it, and I'll have them write it down on their paper before anybody says anything. But normally, and if you want to pause it, you can go ahead and write down what you think molar mass is. But if we're looking at this, we've seen moles, so we know that mole is, what is a mole? A mole is a unit of measure, right? Well, how much is that? Like if I said, what is a dozen, you guys would tell me 12. Well, mole is 6.022 times 10 to the 23rd atoms. So then what's the word mass mean? Mass means I know we like to say weight. Weight and mass are not the same thing, but it's how much substance is there. But we do get that by weighing it, right? By putting it on the scale. So atoms, and then maybe we could put weight, which, like I said, technically is not correct. But we do weigh them. We put them on the scale to get that. So what we're doing then is we're getting the weight. We're putting it on the scale inside the classroom and weighing out a mole. We're weighing out 6.022 times 10 to the 23rd atoms. And that is my molar mass. So once again, we use this on the periodic table. Now it can be confusing because we look at the periodic table for AMUs, but we look at it for molar mass also. Remember that it is a different thing. Like an AMU is different from molar mass, from grams. They have the same number. We use the periodic table to get that, but it is a little bit different. So I'm going to use the periodic table for this. If you use the periodic table, silver, Ag, is 100, and I'm going to put everything up here, 107.8682. Okay, that's on your periodic table. Where I'm getting this, I'm going to put PT. The molar mass of carbon. Carbon is 12.011. The molar mass of sulfur is 32.066. Once again, I'm getting these all from the periodic table. It's that lower number. So that's telling me that 1 mole equals, for silver example, 1 mole of silver equals around 108 approximately grams. So when I'm doing molar mass, it's always going to be in grams. So then I can go and I can weigh this stuff, right? I could go, if I had some silver, I could weigh out 108 grams of it and say, okay, well, there's 1 mole. So let's look here. Molar mass of a compound. So I have calcium, and if I'm using this example, by the way, CaCl2. So number of moles of calcium in CaCl2, there's 1 because there's only 1 calcium here. Okay, the atomic mass for calcium, now I'm going to round because remember those numbers on the periodic table are an approximation anyway, so we're just going to round. So the total mass then is 40. For chlorine, if you look at chlorine, there are 2 moles of chlorine in this thing. Now the atomic mass of chlorine is 35.5. Now remember, I round until I get something that's like right in the middle, and then I tend to keep that. That's just the way my brain works. Some kids round it up. Or I guess with chlorine, actually, you would round that down to 35. So 35.5, and there are 2 of them, so the total mass is 71. All right, so now for CaCl2, there's 1 mole of CaCl2, and about 1 mole consists of 1 calcium and 2 chlorines. So the total mass of this is 111, right? We're just adding these 2 together. And remember, this is all grams. Now that we're in molar mass, it is going to be grams. Our mass is always measured in grams. All right, so this is how we do it. We take the pieces and see how many pieces there are, take the masses of them and add them together. All right, so here's an example. We have K3PO4. potassium, for instance, it equals, it's about 39. So I'm just getting the masses right now of all these. Phosphorus is approximately 31 and oxygen is 16. All right, but there are 3 potassiums. So this is really 39 times 3 is 117. Phosphorus, there's only 1, so it just stays 31. Now oxygen is 16, but there are 4 oxygens, so that is 64 altogether. So then the total weight of this thing, 117 plus 31 plus 64, is 212 grams. All right, I could also say 212 grams equals 1 mole of K3PO4. Okay, so if I wanted to measure out exactly 1 mole of potassium phosphate, I would go to my scale over here and measure out 212 grams of it. That would give me 1 mole. Now that also tells me how many atoms. Like I can look at it and be like, oh, so this is 1 mole, so this means that there are 6.022 times 10 to the 23rd atoms of potassium phosphate in this cup. All right, so here it says sketch below the beaker and the amounts of substance in it. I need to maybe make this a little bit smaller. I might make this a little bit smaller, see if I can here. I just want to make sure. There we go. I'll put it right here so that you guys have room to sketch. So if you can look, I made the water blue because it was going to be a little bit hard. If I would have kept it clear, like, you know, like water is, it would have been a little bit hard to see in this picture. So I wanted you to really see this. So first, salt, for example. Let's figure out how much salt weighs, the molar mass. We've done this before, and sodium is 23, chlorine is 35.5, so this is going to equal 58.5 grams. Water, hydrogen is 1, but there are 2 of them, so it's really 2. 16 for your oxygen, so this is 18 grams is my molar mass. Now carbon, sugar's got a lot more going on here. Carbon is 12, but there are 6 of them, so that is really 72. Hydrogen is 1, but there are 12 of them, so that's really 12. Oxygen 16, but there are 6 of them, so that makes that 96. So my total here is 180 grams is my molar mass. So this picture, I have measured out exactly 58.5 grams of salt. I say exactly, I tried to get exactly. Like it might be like 58.52, but salt, I measured out exactly 58.5 grams, so that is 1 mole of salt. On my water right there, I measured out 18 grams of water, so that's 1 mole of water. And then for sugar, I measured out 180 grams of sugar. So that is 1 mole of sugar. Now, obviously, there's different amounts, right? So sometimes students are like, but wait, a mole, like they tend to get in their heads and think, well, it's 1 mole, though. They're all 1 mole. How can they be different? Well, think of it this way. One of the students in 4th hour told me, oh, yeah, that makes sense. It's like having a ton of bricks versus a ton of feathers, right? It weighs the same. They're both a ton, but you're going to have way more feathers. Like the feathers are going to fill up this classroom, whereas a ton of bricks won't. All right, so they have different amounts of stuff in there, and you can see that. Like H2O, it doesn't weigh as much, whereas, you know, your sugar molecule is a lot larger. That's the same as me going, okay, I want you students to pair up, and you guys all pair up. There's 2 of you, right? There's a pair of you, but all my groups would not weigh the same. All right, so that's what's going on here. So these are moles of each of these 3 substances. All right, so let's do the learning check. The learning check right now is just, you know, making sure that we can get these weights. And it's, like I said, it's very similar to what we were doing in section 1. Just now, instead of saying AMUs and talking about one specific atom, we're talking about molar mass, which is, okay, we're not getting the weight of 1 atom, we're getting the weight of 6.022 times 10 to the 23rd. The same numbers used on the periodic table, but now it's a gram instead of an AMU. So they're different. AMUs and grams are not the same thing, but we do use the periodic table to get those weights. All right, so this learning check, maybe pause it if you want to for me. Make sure that you are understanding how to get these numbers and that you're getting the right thing. But I'm going to go ahead right now and give the answers. Potassium, if you look at potassium on the periodic table, it is 39. 39, and there are 2 of them. Now, I normally don't write the 39 out. I do this thing where I just kind of put a line, and I'm like, okay, 39 times 2 is 78. And then I'm like, okay, I've got one oxygen, which is 16. So what is my total? Total is 94 grams. Aluminum, you look at the periodic table, weighs 27. Now here's what the parentheses, I want to make sure that we're doing these correctly. Oxygen is 16, but there are 3 oxygens. Now when I see OH3 like this, that is telling me that I have 3 of these things, like that. Let's see if I can erase that. 3 of these things. So I have 3 oxygens. I have 3 hydrogens, because it's almost in math, it's like math. Like that 3 is going to the, being distributed to the oxygen and the hydrogen. All right, so 16 times 3 for my oxygen, which is going to be 48. And then hydrogen is 1, but there are 3 of them, so that is 3. So when I add all of those together, my total becomes 78 grams. All right, I'm real quickly want to just, I'm not even going to do weights, but I'm going to do, let's see here, NA, no, I don't want to do NA, sorry. I'm going to do Al2SO. Yeah, bear with me, I'm trying to figure out one that we're going to see some parentheses. There we go, PO4. Guys, I am messing this up, so I want something with a +2. So I'm going to do Mg. All right, I'm going to do Mg, and I'm going to do PO4. So this would be Mg3, PO4, 2. There we go. Need to get my charges to crisscross. All right, so if I were looking at this, I have 3 magnesiums, right? So I'm going to take 3 times 24. I have 2 phosphorus. So I'm going to take 31 times 2, and I have 8 oxygens right now. So 8 times 16. I'm not going to do the math on all that, but I just want to make sure you guys realize that 3 magnesiums, 2 phosphorus, 8 oxygens. It is the distributive property. This PO42 means that you have 2 of these guys. So look, 2 phosphorus, 4 and 4, that makes 8 oxygen. Okay, and then lastly, the learning check. Let's see if I can get that off of there, right there. Get that down on the next. There we go. All right, so this learning check, guys, it's just Prozac. It gives you a lot of information that you don't need. But Prozac is C17H18F3NO, is an antidepressant that inhibits the uptake of serotonin by the brain. What is the molar mass of Prozac? So it gives you a lot of information, but what are they asking for? And you guys will see me do this over and over. I will box in, what do they want of me? Because some of these chemistry problems can be very wordy. So what do they want? They want the molar mass. So I'm just going to add all of these together. So carbon, for instance, let's do carbon here. That is 12, but I'm going to multiply that by 17. All right, that's going to give me 204. My hydrogen weighs 1, but there are 18 of them. So that's going to give me 18. Fluorine. Fluorine weighs 19, but there are 3 of them. So that's going to give me 57. Nitrogen, this one's 14. There's only 1 of them, so it's going to equal 14. And then I have 1 oxygen. It weighs 16, but there's 1, so it's going to stay 16. All right, so my total, and once again, you don't have to write all of that out. I didn't on my sheet. I did not write all that out. I want you guys to make sure that you know where I'm getting these numbers. All right, and once again, these masses, the 12, the 1, the 19, 14, 16, that's all coming from your mass on your periodic table. When you add all of these together, 204 plus 18 plus 57 plus 14 plus 16, that is going to give you a total of 309 grams. All right, that is a big molecule. So if I were to weigh out a mole of it, yeah, it's gonna take up quite a bit of that cup. Like if I were to pour it into a cup like I did the salt, sugar, and water. Whereas, you have some things that just aren't that heavy. So anyways, that is it. It's just going to be, right now, just adding these together, getting the mass, and then starting to realize, hey, that is 1 mole. The next section, which the homework is going to kind of get you started on this path, the next section is, okay, well, if 1 mole, for instance, let's use that learning check. If 1 mole equals 309 grams, how much does 2 moles weigh? How much does 3? People can do that and they know, oh, I'm going to multiply. Or what if I start saying, okay, well, what if you have 7.256 moles, how much does that weigh? Or we could do opposite. I could say, hey, I found some salt and I have 28.7 grams of salt. How many moles is that? So that's where we're headed at in section 4. All right, if you need anything at all, let me know, and have a great rest of your day. Bye.